Good morning, dear students. As we are moving into the topics, there is a new topic that has to be taught, which is very important for 5 mark question. The name of the part is microbes help in sewage treatment. That means how microbes digest the sewage water. Sewage doesn't mean that it is from sea, but sewage water is the water that has been created or like polluted by a given area like a town or a city. All the water basically will be moving. Look at here. Basically, if in a given city, all the wastewater consisting of mostly the human excreta, the waste created by humans, and also a lot of water which has been uh, thrown out of the each and every house in a given town will be diverted to go into the river. So this is the river. So it is like disposing the water from the city directly into the river. This is a major thing because the wastewater contains so much of pollution. That means it can be like filled with many undesirable, unwanted chemicals which may disturb the ecosystem in the river, or we can simply pollute the water which is flowing in the river. So, in order to treat this water, like a century ago itself, there is a set of things that has been installed by the government, which we commonly call it as a sewage treatment plant. Sewage treatment plant is the one which is standing middle between the movement of water from the city into the river. So sewage water has to be treated before it is diverted into the river body. So that we can prevent the pollution of the ecosystem of the river or disturbing the water quality in the given river body. So now, since this chapter is all about how these microbes, some of the microbes help in treating the water, that is sewage water, which is so toxic, which is highly polluted, it can be reduced by the action of the microbes. So microbes helping the sewage treatment so that whatever the water that is going or diverted into the river will be less polluted. So microbes do a lot of work right over here. So that is what we're going to learn in this given topic. Okay, let's see. Now, for our own convenience, to make you understand in a better way, the whole process of sewage treatment plant is explained in this way. Looking at this, I have drawn a easy diagrams so that I can explain you in an easy way, so that you can understand. While revising, you can take this screenshot and then you can revise it also. So what I'm going to explain in the beginning is that the water moving from the city from this side, and then here you can see the water being diverted into the river water. So consider like this. That means the whole process that you see all the way in the middle that is happening in this whole thing is a sewage treatment. Okay, imagine it's a sewage treatment plant, and it is a whole process which can be divided into small steps so that you can understand better way. Okay, let's start from the beginning. So water which is coming all the way from this side is highly polluted. So I can write here highly polluted water. Okay, let's move to the first treatment here. Now here you can see the water from the given town or a city has to be moved into the very first treatment called primary treatment. Okay, remember the water is moving into this chamber. In this chamber, what happens is that the very first step is mechanical separation. That means people go into this water and then mechanically remove the floating debris. These are the things which are floating on the surface of water, and also physically, manually, the pebbles or the small stones inside this can be removed mechanically. So first step is mechanical separation of the debris. Anything, it can be the floating things, and the ones which are settled at the bottom can be physically removed. Okay, the second one, it has to be undergone filtration, like mechanically only, and let that after the filtration, then sedimentation has to be done. That means leave it for some time. Leaving causes to produce a type of material called effluent. So anything that settles at the bottom or anything that is at the top can be considered as effluent. Remember this. So that means in the first treatment, mechanical separation, filtration and sedimentation leave certain thing that is called effluent. Okay, so this effluent is moved into the next tank called secondary treatment tank, or you can call biological treatment. In a simple way, we can call movement of effluent takes place into a type of tank called aeration tank. Aeration tank is simply this tank is having large holes where air can be pumped into that chamber. Okay, so now consider this, that effluent has been filled, okay, and it is supplied with a lot of air. So air is supplied, and in this chamber, the reason why we are calling it as biological treatment is because in this chamber there are certain type of bacteria and fungi grows, and both bacteria fungi together look like a big mesh, like a lump of material which is already been present inside this biological treatment, which is commonly called as a flock or flocks. Remember, this is very important 1 mark question. Flocks are nothing but a lump of bacteria, fungi growing together. That's the reason why it is termed as a biological treatment. That means, imagine this is the lump of or a mesh of flock being already present in the secondary treatment tank. So now effluent has been moved into this chamber. So what happens here is the very first step is agitation. Agitation means continuously water is like agitated. Agitated is simply rotating the whole water mechanically, or you can say like a big blades or turbines are present which keep moving, agitating, causing the water to get disturbed. Okay, remember that agitation means simply like in order to make buttermilk, what we do, we agitate, isn't it? This agitation causes the water to get disturbed, so that the water with the organic matter will be distributed in the whole chamber. So this causes, remember the most important one, this kind of a treatment or agitation leads to the bacteria and fungi to actively consume what? All the organic content present in the effluent. So all the organic content, that means all the living part of the effluent will be consumed. So keep that. Both bacteria and fungi, both are living, which together called as a flux, act upon this effluent. What it will do? It will digest the effluent and consume, that means it will digest and take all the organic content in the effluent. Fine, that is the second point. So what happens is, while it is consuming the organic content, it requires certain amount of oxygen. Okay, remember that. So flocks consisting of bacteria and fungi require oxygen. That oxygen required by the bacteria to consume the effluent is called BOD. In an expanded position, it is called biological oxygen demand. So that means, let me go back and here in the textbook part only, and then I'll show you what exactly biological oxygen demand meant. Okay, look at here. You see right over here, BOD refers to the amount of oxygen that would be consumed if all the organic matter in the effluent were oxidized by the bacteria. It's like the amount of oxygen required by the bacterium or the flock to reduce or oxidize the effluent. Okay, so here you can say the rate of uptake of oxygen by microorganism is in the sample of water. In a clear way, you can say the oxygen acquired. So it means that the greater the BOD of the wastewater or the effluent, the greater the BOD of the water of the wastewater, the more its polluting potential. So you can say that when the bacterium and the fungi start digesting the waste material, it requires the biological oxygen demand. Thus, the whole effluent greatly reduced, causing it to become more and more polluted. So more the BOD, what we have learned, the greater the BOD of wastewater, that means greater the BOD of wastewater, the greater it will be the pollution potential. So that's the reason why the BOD must be reduced. Okay, so in order to reduce the BOD, this secondary treatment tank require flocks. That's why it is called biological treatment. Biological treatment means digestion of the effluent by the action of flocks. Okay, so let's move to the next treatment. This is the second one, and here comes the third one. The third one, which is called a settling tank. All the effluent after reduction of the BOD will be moved from secondary treatment tank to settling tank. So what happens is, in settling tank, the effluent is left for settlement. All the things that are present inside, whose BOD is greatly reduced, what happens is this will become activated sludge. Anything that settled at the bottom is called activated sludge, and also all the wastewater whose BOD has been reduced will be at the top. Okay, so activated sludge is nothing but the leftover flock. So this flock that we have already heard here, a little amount of flock is being moved back into the secondary treatment plant to act as an inoculum. So you may ask me, where does this come from? Where does this flock come from? This flock is coming exactly from the settling tank only. So every time a new effluent moves into this, the already already present flock that is been moved into settling tank will be a little amount of flock is moved back into the secondary treatment, so that the bacterium and flock will be reused for treatment in the in the biological treatment. Okay, so now by this time the whole effluent has been greatly reduced at its pollution potential. So the less the BOD, the lesser the potential of the polluting property. So after this, the water or the effluent is moved into next chamber called anaerobic sludge digester. In this, all the effluent will be settled and provided with anaerobic conditions. You know what is anaerobic conditions? Anaerobic conditions is the condition where oxygen is not supplied. So thus it causes the bacteria to actively digest all the effluent if there is any organic matter present in it. So anaerobic sludge digester allow the production of even biogas also, because it is occurring in the absence of oxygen. Thus variety of bacterium which is anaerobic in nature digest all the effluent, greatly reducing the polluting potential. Thus whatever that effluent that has been completed the anaerobic sludge digestion will be moved into the river. So once it is moving into the river, the water gets less polluted, or there is no pollution, thus making the water moving into the river become less polluting. Okay, so this is how the sewage treatment plant work. I hope this makes some sense here. So the main point from this chapter which you should be knowing is that, remember, process how where at what places the microbes are helpful. Like here you can see in the secondary treatment as well as in the anaerobic sludge digester, which makes the whole effluent to become more and more less polluted.